Hi, so documenting again on my robotic arm. So this term I have designed the arm like this. So it's a bit different. It will be a bit sturdy. I have changed the motor as I promised. There will be 6 motors. 4 motor will be MG996R. This motor is pretty powerful. I've learned my lesson and I'm not taking any risk. So MG996R will be here, here, here and here, and I'm planning to give it a call. So I'll use 2 servers for it. Well, another design you can do a bit differently. Wait, terminate. Wait. Another design I have seen the claw for is wait. Wait, terminate. There's a circle. What the fuck? Oh, come on. Wait. Let me draw here. There's a circle. Claw. Claw, 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 claw. There is a servo under it. And there is another one. Claw, 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 claw. And the claw is from here. So there is one servo only. Yeah. And I've seen there is 2 nuts. Okay. I'm not using this one because I don't have the material and I'm not working with aluminum, and I am not using a 3D printer also, and I'm using this thin board, so it is not sturdy. And see, if I press it here it will break, so I can't make design like this. So I'll make a design like this. There will be one servo S90, and the claw will be like this. It's pretty easy. So I have designed the lower part so far. It is the lower part. Wait. So here's a motor, here's a servo, and here's a bearing, a small bearing, like see. So all the weight would be on this point and it will be distributed to the structure, so the servo will only rotate the arm. And here's the second servo, and it is for this part, right? It will go like this. But as for my design, it will go the other way and it will go like this. I have used copper wire because, as I have said, I don't have a 3D printer and I'm not working with aluminium, and I'm just making a prototype first, and I will make a robot arm with metal. So I'm not I I have using like this kind of thin board just to make a prototype. So these are copper wires. I can't tell you the diameter exactly because I didn't need to know. There is 100 gram copper. I made a mess. So yeah, I'll report it after I have made a big progress. Hi, documenting again. So I've made some progress and I've made this structure. So I need to test a lot, try a lot to see what works, and the material isn't sturdy. So I use needles to keep them up. I've used ball bearing in joints. Copper wire. Yeah, I'll fix that. Wait a minute. Yep. And I've added 3 ball bearing here, and this side. For a proper weight distribution. See? So there is a servo here under. So if I rotate this motherfucker, it will rotate also. But I think I have kind of made an error with the lower part of the arm. So the bottom servo isn't accurate, it is twisted. So I'm a bit upset. So I'll tell you when I am moving the servo. Okay, moving. So you can see that the arm part hasn't moved yet. So I'll move a bit more and it will start moving. So it pisses me off so much. It took me around 12 hours to make this little shit, and it turns out to be a shit. Come on, you fucker. Wait. The arm should be like this. but I'm not moving the motor. The freaking wire is twisted. It makes me so mad. I'm sounding a bit husky, right? Well, I haven't slept since 8 o'clock in the morning and it's 3:30 at night. I have been working on it all freaking day and it pisses me off that it didn't work. But anyway, I'm gonna finish the module. It will be another error and it will be another prototype, and I will make a better design in the future and it will be much more better, much more sturdy and most of all usable. So yeah, I'll see you after I have modified it a bit more and I'll document it after that. Hi, documenting again. This is the final part for the mechanical design with this board. So yeah, this will be the final documentation for it. And the next documentation I'll do on programming the arm. Okay, so yeah, I have completed the design and I needed to make a few changes to the arm space and I had to make a bit different design than what I initiated first. The grip design with a multi-purpose hand. Right. So my room is a bit mess. I have become a bit messy. So I apologize for the mess and please excuse the background noise. There's constructions going on and please bear with me. Okay, this is the design. I have redesigned the base. Here is the base and here is small pins like these ones. So these pins are about this size. So I have used glue, but glue doesn't work very well. So these are like nails with wood. Okay, it is pretty hard. So I have used glue and then nails to take the weight from the arm. This is the base and these are the bearings. So there is issues with this arm's base motor because the part that is rotating the motor like this, it was very bad and I have redesigned it so it is now pretty good. So this motor, it starts from here and for the hand it will go from here to all the way to goes almost 270 degrees. So I think it will start from here and end in here. It's pretty good. So yeah, all 80 degrees. As I've said, there is copper wire to bind them, so it is pretty hard. Let me show you. Here I've used screws and this part, so you can add any kind of arm. Like if you want to add grip, you can add that. It is pretty hard. it can take pretty small weight, but that's very good. Okay, so this is the arm. Okay, so let me show you. Here it goes right here. Okay, and this arm, let me show you like this. This arm goes from here to this part here. Okay, and this portion, the base portion, it goes like, wait a minute, this. So yeah, it's pretty hard. So this 1, 2, and another bearing, this one is taking all the weight from the arm, this whole portion, and it is distributing the weight in this part. Okay, so the motor is pretty fine and there is no weight on the motor, and this design is also the same. This part of the arm is taking weight and the weight goes to the bearing and this bearing, so the motor is only rotating the arm. I have used copper wire because it takes 1 second. The birds are not very good. See, this part, these are not very good. I will make another design and that will be with aluminium. My goal is to make it with aluminium, but I might go with the steel first, and I don't have a lot of experience with aluminium and steel work, so I had to learn them. It's pretty easy for me, this kind of stuff. You'll just need to show me just one time and I'll be able to do it. Yeah, I have that confidence. I'm very good with engineering stuff. So this one is the same. The whole weight goes from here to this bearing. And it is sad to say that I haven't calculated this whole arm, even though I was reading a book about it, but I needed to first see if this material could even take the weight. So I had to make a prototype. Yep. Yeah, it's pretty hard. It's pretty good. So yeah, there is a motor here, and there is the second motor, third motor, and the last motor is inside of it. This design is pretty good, and I have used only 3 bearing, 1, 2, and this part 3, because I have seen that this part doesn't take very much weight. Okay, so I haven't added any bearing to this, and look at this. The whole arm, the motor will distribute the weight to this line. So these 3 bearing, I think okay. I haven't calculated anything, but it was a bit pretty hard to design this one without calculation, because even if you're making it like this, without any kind of uh, proper metrics, it is pretty hard also. So yeah, this kind of arm is pretty hard to make. So the most hard part for this is the mechanical design. I had to take a lot, I had to distribute the weight, and you see I have made this kind of design. See, it's a bit tilted, this part. I've seen that if you are taking weight from this side and see here's weight, and this motor gives a force to this direction, and that is also part of the hand and it is connected with it. So this part I have seen could take the weight more, so the motor is from here, so it takes the weight from this, and if the weight is on this side, so I have seen that it distributes the weight very good, unlike this design which is tilted in this side, and I have seen it shows a bit of problem with the weight distribution. So I've seen that if we're picking up weight like this in this direction, the board tilted like this works very good compared to this rotation of the board. So yeah, this design, I had to design it, redesign a bit, and I will connect it to the power supply and I'll see how the robot goes. And let me show you another thing. This whole part I have is glue. So yep, I have his glue, but I have used these pins heavily. It's very hard, and you see this part I've used these pins. It's very hard and it takes the weight pretty good. See, I have used these pins everywhere. I have used these pins here, see? So it takes the weight from the base arm, the base motor. See, I've used the pins also in the bearings. It works like, see, the pins, it works like wheel, and there is also the pin, and there is a copper, right? Copper is pretty good, and here there is this design has used copper, and I have found this design very useful. I wanted to make it circle, but this board is very thin and 5 millimeter, and if you want to make circle, it should be very good. So I made a kind of octagon. It's pretty good. So let me show you how hard this bird is, and how hard this design is. Let me show I have apologized first that my room is a bit messy. So let's see. Wait a minute. I will tilt the arm totally, and it works fine. Okay, it works fine. It works pretty fine. See, it works pretty fine. Right. So yeah. Yep, my room is a mess. Got it. So this baby have told it shit, but it turns out to be good, and I'm sorry. That is a bit dramatic, isn't it? I sometimes feel like I'm an asshole trying to show off things, And I'm truly sorry for that. Not really. I'm a bit tired. Not from working with this, but other stuff. So, yeah. I'll stop the documentation, huh? And thank you for watching this part of the documentation. And for now, there's my baby, kind of. Not really, I don't care. The design is pretty bad, not accurate. But we have made progress and I'm fine, happy with it. It took 36 hours straight, worked for 4 days. Had to design it, 36 hours of labor work, okay? Just labor work, 36 hours in 4 days. And I had to design the arm, a lot of it. It was pretty hard. So yep, I will quit the recording now. And thank you for watching. Hi, documenting again, and this is my final documentation for my robotic arm design too. Okay, so I programmed the robot a bit. I have used some new components to program the robot. No, I didn't. I used the same Arduino Uno. What I meant to say was I used new program to control the servo more efficiently. So at first I was trying to control the servo manually with capacitor and resistor, but I figured that using a servo would be much better choice, the servo controller. So I have used a servo controller, and it is PCA968516 channel servo, this one, and it takes 5 volt 5 ampere current. And I have used a power supply, this is this one. So this is the AC cord and this is the output power. So yep, this is connected with the AC cord and that's how we go. And I've used Arduino Uno, which I will be controlling with the joystick, and that is the robotic arm. So let me just first show you the demonstration and then we'll see the code. Right. Okay, so I'll take the arm, the joystick, and we'll see how it moves, okay? See. Here is the first one, the first motor. See? This one. Okay, let's see if it can take the weight, and it will be the second one, and the second one is this one, okay? So we'll go there along the y-axis, so it can perfectly take the weight. See? It's a beauty. So let's keep it there. And I'll take the second joystick and it is for this one. So I'll move along the x-axis. See? It moves smoothly and it is not okay. I mean, not that smoothly, but it runs okay. I designed this robot, come on. It is sweet on, it's a sweet baby. Okay, so I'll use it again. And I'll go on this side. Hey. Hey. And then I'll go this side. See? It looks like a bottle. And now I'll take it to its original position. So yep, that's my... It's not my baby, it's got problems with this motor. and I figured that there would be some problem mechanically, so I didn't program the robot before, and programming the robot is the easiest part. Designing it is very hard. So this motor doesn't work. The gear between this motor has cut off, is damaged, and I will need to replace the motor. But this whole design that I've designed is perfect. For me, it's perfect. Only problem is that when this motor gives the power, it is a bit off balance. So I will need to modify this base portion if I want to make it with aluminium, right? Of course, I'm asking you, right? It's that. If I want to make it with a bit more weighty material, then I'll need to change this motor and all will be okay. Okay, so let me show you the code. Right, this is the side that I use for this motor, and let's see, wait a minute. Has the code for it, and it's a very simple code. I use this joystick portion. You see, this whole portion is the joystick, pulses, servo motor, and there is a setup port. This line, you don't need this line. I can omit it, but it's okay, I haven't done anything. And this is the loop port. It's just for debugging. I'll delete this portion. Yeah, this is pretty much the code. So yeah. This robot is it for now, and I'm not sure that I'm gonna make another robotic arm very quickly in distant future. I'm not sure about that, because this works just fine. The motor is a bitch, and the next time if I want to make it, I want to make it with aluminium body, and I'm not gonna fuck around with any kind of useless material. I made it just for prototype. If it even can take the weight, just to see that. So next time, I think it will be a while before I make another robotic arm. This one is very perfect. This design is very good. The motor is a bitch and asshole. Other than that, it's fine. So let me say goodbye to you, right? And I'll make this one make goodbye also. Bye bye. Bye bye. You say bye too. Come on. Bye bye. Okay. Bye.